The script component is the data flow component that you use to add all three types of custom code: data sources, data destinations, and data transformations to your data flow. When you add a script component to your data flow designer, the Select Script Component Type dialog box appears, prompting you to select the type of component that you want to implement with script. As you can probably imagine, data flow scripting with the script component is more complex than control flow scripting with the script task. You have many more options as you process data rows, and these options yield more complexity. One of the biggest differences between the script task and the script component is in their execution of code. The code in the script task generally executes only once when control passes to it, but may execute multiple times if it's within a loop container. Either way, it's likely to be a very small number of executions. The code in the script component, on the other hand, generally executes once for each row that passes through the data flow. As you can imagine, this makes the details of data flow code quite different from the script task. Similar to the script task, the code in the script component defines a script main class, but that's where the similarities end. The script main class for the script component inherits indirectly from the Microsoft.SQLServer.DTS.Pipeline.Script component class. This enables your code to access a great deal of core data flow functionality through the script main class itself, as opposed to using a helper object like the DTS object from inside the script task. In addition to the script main class, the script component's Vista project also includes an output buffer wrapper class. The name of this class is based on the name of the output that you define on the Inputs and Outputs page in the Script Components Editor dialog box. For example, if you use the default output name, output0, the class's name will be output0buffer. In your script component code, use the methods of this class to send rows to the output of your component. In addition, if your script component has multiple outputs, and I'll talk more about that later, your Vista project will contain multiple output buffer wrapper classes. So it really is reflecting the environment in which this script component is executing. Before you learn about data flow scripting code, you need to understand how to configure the script component. Because the script component exists primarily to manipulate data within an integration services data flow, you need to configure the input and output columns for the script component before you start writing code. You do this through two different pages in the Script Transformation Editor. The options that you specify in the editor help determine the properties of the script main class in the script component's code. And by the way, even though a script component can be used as a data flow source, a data flow destination, and a data flow transformation, the name of the script component editor is always Script Transformation Editor. No idea why Microsoft chose that as the default. Maybe they just thought that more often the script component is used for transformations. I don't know. Okay, so on the input columns page of the Script Transformation Editor, you specify which input columns you'll work with and in what way. As with most data flow components, you need to connect the script component to an upstream data path so that the column metadata is available before you set these properties, unless you're using the component to create a data source. For each input column, you can specify the usage type, either read-only or read-write, and the output alias that the column will have after passing through the script component. And then, on the Inputs and Outputs page of the Script Transformation Editor, you can fine-tune the properties of the input and output columns. You can also add new output columns for columns that the script component will add to the data flow, and add new output paths if your component will have multiple outputs. For an example of a transformation with multiple outputs, think of the lookup and conditional split transformations, where a single input produces multiple outputs, normally. Now, it's a best practice to give your inputs and outputs meaningful names that represent the data that they consume or produce. This will make your code and your package easier to understand and maintain. Frankly, the name input0 is just not going to make any sense to anybody. It's a best practice to give your inputs and outputs meaningful names that represent the data that they consume or produce. This is going to make your code and your package much easier to understand and maintain. Names like input 0 and output 0 just don't make any sense to anybody. I suppose it's okay if a component really has only one input and one output. It's pretty unambiguous in that case, but it's still better to document what's coming in and going out. Now, data flow components can have inputs, outputs, or both. And as you'll see, the script component type you create determines by default which sets of columns it has. When you add a script component to a data flow, Integration Services prompts you, using the Select Script Component Type dialog box, whether the component will function as a data source, destination, or a transformation. The choice you make is crucial. It determines whether input columns, output columns, or both are available. It sets up different code modules and files in the Vista project and affects how you write your code. So before you get started, you need to know what the function of this component is going to be. Again, a data source, data destination, or transformation. So let's talk about the script component as a source. So in this case, you're going to use it to create custom data sources, which insert data into the data flow. This means that the component will not have a data input stream, but will somehow produce data and send it to its output buffers. The script component as a source has several distinctions from the two other types of components. First, it has outputs only. It's a source of data, so it's only producing data. So there's no inputs. This makes sense when you think about it, as a data source only produces records. It doesn't consume any records. In fact, the Script Transformation Editor dialog box does not even have an input columns page. And then you use the Create New Output Rows method, which is part of the script main class within the Vista project. This is where you add custom code to write rows to your component's outputs that transformations will use later on within your data flow. And then you need to use custom input. Most of your code will implement the logic to read data from a custom data source, not using one of the providers that's provided by Integration Services. Or it might produce data on the fly. Maybe it's the whole purpose of the data source is to generate random numbers. And that's all it does. It just spews out random numbers and puts them into the data flow. The important thing to understand is that all of the data that forms the component's output is generated in your code, perhaps from resources outside of your package. So maybe you use XML features of the .NET Framework to read a source XML file, custom file of some sort. That would be another kind of scenario. And then for writing output, in order to write data rows to an output, you call the add row method of the output buffer wrapper class. To signal that all the rows are written, you call the end of row set method of the output buffer wrapper class. So there are methods that you would use with the script component only if it's a data source. Okay, next up is script component as a destination. So you can also create custom data destinations. And this is going to store data somewhere. And it has a couple of distinctions from the two other types of script components. It has inputs only, sort of. So it has inputs only, no outputs. And again, this makes sense because a data destination only consumes records. It does something with them, but it's not going to continue them along the data flow within the data flow part of the package. And what it's usually going to do is persist them someplace. The one exception is that you could have error outputs. So that's why I said sort of. And then you use the process input row method in this type of component. So again, the Vista project includes a script main class that has this process input row method. And that's where you add custom code to that method to take the rows that the data flow provides and write them to your custom data store. Most of your code is going to implement logic to read data from the data flow, the inputs, and then write data to a custom data store that your component is designed to support. So it's some sort of custom output. Again, it's not sending it down data flow pipeline any longer. It's doing something with them. And then it's writing output. You add your custom code to the process input row method. And that method is called once for each row that is sent through the data flow to your destination, and that's where you persist the data, if that's what your component does. Okay, and then the third kind of use, or third type of use for the script component is as a transformation. So, even though you can use the script component to create custom data sources and destinations, you're probably going to find that you use them for those purposes relatively rarely, just when you need to deal with some custom data source or destination. Instead, you'll likely use the script component to create custom transformations, most of the time. And appropriately, transformation is the default choice in the Select Script Component Type dialog box. The script component as a transformation has a few different characteristics that distinguish it from the other types of script components. It has both inputs and outputs. This continues to make sense, I hope, because transformations are the building blocks of integration services data flow. Transformations consume data from a data source or another upstream transformation, and then provide data to another downstream transformation or to a data destination. The main methods that you use here are the process input row method and process input method. And again, these are methods of that script main class. So process input row is where you add custom code to take the rows that the data flow provides and write them to the component's outputs. And then you use the process input method that lets you work with all the data flow at once. And most of your code is going to implement the logic to transform the data rows as your components process them. All right, so far I've been talking about synchronous data flow script transformations. But this is not the only type of transformation that you can create with the script component. You can also create asynchronous transformations. So what's the difference? Well, synchronous components produce the same number of rows that they consume. They can modify data in columns, but do not create any new rows. Another difference is that synchronous data flow transformations start sending output rows to downstream components prior to receiving all input rows from upstream components. Okay, but asynchronous transformations, on the other hand, may not produce the same number of rows as they receive, and may need to wait until they receive all input rows from upstream components before they send rows to downstream components. Now, to understand the difference between synchronous and asynchronous transformations, consider the derived column, aggregate, and sort transformations, the built-in transformations within integration services. The derived column transformation is a synchronous transformation. For every row that the component consumes, it produces exactly one row. Although the data in the row, and even the number of columns in the row, may be different in the input and output, the row count is the same, and the component produces rows as soon as it consumes them. Now compare that to the aggregate and sort transformations. These are both asynchronous transformations. The aggregate transformation is asynchronous because it may not produce as many rows as it processes, depending on which data fields you set the transformation to group the results by. The sort transformation is asynchronous because it has to process the entire set of input rows in order to sort the data properly before it can produce any output rows. If there's still rows that are coming on in the input, it doesn't know if those come before or after the rows that it's already sorted. So it needs all of the rows before it can produce a sorted output of the rows. An explanation of the detailed differences between synchronous and asynchronous data flow components, it really is largely beyond the scope of this course. It's a pretty intense set of differences. But you need to be aware of several things when you use the script component. When you develop a synchronous transformation, you never create any output rows. You programmatically manipulate the rows that the integration services runtime makes available by passing the row parameter to the process input row method. But you never need to create your own rows or write them to your component's outputs. Within the process input row method, you have access to the current data row being processed, which is automatically written to the component's output when the method's execution is complete. When you develop an asynchronous transformation, you have to explicitly create all output rows. Instead of using the process input row method, you usually use the process input method. The process input method provides access to the full input buffer instead of only one row at a time, so it's great for aggregates, for example. Within the process input method for an asynchronous transformation, you can call the next row method on the input buffer to navigate through the rows. When you have output rows to produce for an asynchronous transformation, you call the add row method on the component's output buffer. And after you produce all output rows for an asynchronous transformation, you call the set end of row set method on the component's output buffer. This notifies integration services runtime that the full output buffer is ready and the component's execution is complete. All right, then it's a little bit more complex. There are two types of asynchronous data flow components: partially blocking and blocking. Blocking components do not create any output rows until all input rows are processed. An example of a blocking component is the sort transformation. Partially blocking components do create outputs while still processing input rows. An example of a partially blocking component is the union all transformation. Now, each type of asynchronous component requires different programming techniques. But the previous list that I talked about should provide enough information to get you started. All right, so at this point you're probably asking, that's all well and good, but how do I notify the integration services runtime that I'm building an asynchronous transformation so that it calls the process input method and not the process input row method? That's what you were thinking, right? Well, the answer to the question is simple: metadata. The entire integration services data flow pipeline is built on metadata, and the script component is no exception. Each input has a unique integer ID value that integration services uses to identify it. Each output, in turn, has a synchronous input ID property that specifies which input provides the rows for the output to produce. Most script components have one input and one output and process rows synchronously. And in these cases, the default value is appropriate. But if you're developing an asynchronous component, you need to explicitly set the synchronous input ID property for your component's output to none on the Inputs and Outputs page of the Script Transformation Editor dialog box. So setting that synchronous input ID property to none modifies the package metadata and, more specifically, the script component metadata. And then once you change the synchronous input ID property, you have to update your code to use the process input method instead of the process input row method.